Okay, today we'll do that magnetic field due to a current carrying conductor. And yesterday we did the ostrich experiment. No, that Hans Christian Ostrich has given the relationship between the magnet and the current. Now here also we'll just discuss. Yesterday we discussed that suppose if you connect a battery here, clear, that is one or two cells in a conductor wire, and you have a that switched, okay, and by that switch you can control the current flowing. Okay, if you switched on the through the battery, the current will flow. Clear? That means current will flow. And how to show? Obviously, how he has shown that there is magnetic effect or not by using the needle, compass needle. If you keep the compass needle near that conductor wire, if there is current is flowing, then that compass needle will show the deflection. Deflections means there is magnetic current, there is magnetic effect. With that we have identified it in our yesterday's experiment. And for this also the same way, if we change the polarity of the battery, clear, first suppose if you keep positive downside, negative upside, just change the polarity of this battery. Polarity, that is positive लाई नेगेटिभ को जग्गामा, नेगेटिभ लाई पोजिटिभ को जग्गामा राख्नु. क्लियर? अनि त्यहाँदेखिको again repeat the experiment. Switched on gara, as well as if you switched on, what happen, the current will flow. Current के हुन्छ, flow हुन्छ. अनि current flow भएपछि if you place the compass needle near to that copper wire, conductor wire को छेउमा लाँदा के हुन्छ, that will shows the deflection. Suppose only deflections current positive पट्टि left पट्टि deflection first हुँदैछ नि, if you will change the polarity of the battery, that time the deflections will also change. Clear? That means if you change the polarity, suppose current is in the north direction, just look at here suppose passing current towards the north पट्टिको directions मा current pass हुँदैछ नि, deflection will source towards the west directions मा. Clear? And likewise if you change the polarity, अब अर्को फिगर्स मेरो, if you change the polarity change गरे भने अनि प्रोसेसलाई सेम रिपिट गरेर त्यो कम्पास निडललाई छेउमा कम्पर वायरको छेउमा लाँदा, and the directions of the current will be from north to the south, then the deflections will shown towards the east directions. Clear? That means this is the magnetic field. Current carrying conductor ma magnetic field say, if you change the polarity of the battery, that time the deflection, magnetic field also change. Now in this chapter, in this we'll do the magnetic field due to a current carrying a straight wire ma garchau, अर्को curved wire ma, and last one for the solenoid. Clear? Now for the magnetic field due to a current through a straight conductor. अब हामीले चाल पायो, if you change the polarity हैन, current carrying conductor को magnetic field को battery को polarity change गरे magnetic field को directions also change. अब यहाँनिर first for the magnetic field due to a current through a straight conductor. अब यसको लागि you just take one cardboard, okay, cardboard लियो, cardboard को बीचमा make a hole and place one copper wire. Clear? अब copper wire, अब यहाँ चाहिँ अब हामीले magnetic field कस्तो खालके पाउँछ, magnetic field due to current through a straight conductor. Now place copper wire and make a circuit like this. Just look at here, place a cell also, and here also make a switch also, and if you and on that cardboard place some iron fillings. अब iron fillings बाट magnetic field छ नि त, iron fillings के हुन्छ, it makes a pattern, isn't it? So iron fillings to cardboard मा हाला, you just make a figure like this. Clear? यहाँनिर सबै चीज छ. Now suppose you are passing a current, अब current pass गर्दैछ, हाम्रो polarity suppose positive we all know all current always pass from positive to the negative sides. Positive देखिको negative sides मा pass हुन्छ. Just look at here. अब यहाँनिर हेर, you just look at this figure. From this positive sides current is flowing. अनि current flow भएपछि यहाँनिर यो कार्डबोर्डमा पनि आउँछ अनि यो आइरन फिलिङ्सले it makes a pattern. अब यो यस्तो खालके डटेड यहाँ र सर्कल, this pattern it will forms. अब यहाँनिर we have to identify polarity. Suppose this current को okay, when we'll give current from, suppose current is in that cardboard, if the current is from upside to downside, मुनिपट्टि current flow हुँदैछ भने that iron fillings will make a pattern, that is the circular pattern clockwise. बुझ्यो? कुनै पनि करेन्ट चाहिँ त्यो त्यो कार्डबोर्डमा आइरन फिलिङ्स रहेको कार्डबोर्डमा चाहिँ करेन्ट चाहिँ माथिदेखि मुनि झर्दैछ भने चाहिँ कसरी त्यो प्याटर्न फर्म गर्दो रहेछ? क्लकवाइज. Clear? And likewise, if you change the polarity of the battery, positive like negative, negative like positive, that time the current flowing also change. If that flowing current is flowing from downside to upside, माथिपट्टि current जाँदैछ भने that will forms that त्यो iron fillings ले कस्तो कतापट्टिबाट pattern form गर्दो रहेछ? anti clockwise. Clear? Current मुनिपट्टि flow हुँदा clockwise and माथिपट्टि flow हुँदा anti clockwise pattern will form. जुन चाहिँ हामीले कार्डबोर्डमा आइरन फिलिङ्स हालेको छ त्यो आइरन फिलिङ्सले pattern, different patterns will get. That means the current. अब यो बुझ्नुको लागि you have to understand the right hand thumb rules. We have right hand thumb rules. For this also, suppose you all know the right hand thumb rules, and this thumb denotes the current flowing, and this call part denotes the magnetic field. Magnetic कहाँ pass हुँदैछ, and you have to remember magnetic field always in the circular path will get. Clear? अनि current चाहिँ कि upward बाट जान्छ downside कि downside बाट upside. अब यो right hand thumbs rules बाट चाहिँ will understand that suppose this is the thumb. अब यो thumb, suppose current is flowing, this thumb denotes the current is flowing in the upward directions. मैले just now I discuss current कुनै पनि iron fillings को through upward मा जाँदैछ भने that means this call part कतापट्टि moves हुँदैछ? anti-clockwise. That means this curl part denotes the magnetic field. Anti-clockwise के हुँदैछ? magnetic field. current माथिपट्टि छ भने magnetic field anti-clockwise हुन्छ circular path मा. Clear? Likewise, अब suppose this, look at here, suppose this is the conductor, current is flowing in the downside like this, and this nothing, that means you just remember, suppose this is the wire, okay, right hand thumbs rules going. Suppose this is the copper wire and current is moving towards downside. अब current downside मा हुँदा मैले भने magnetic field कतापट्टि, suppose this is the thumb, okay, and this coil part, this is the magnetic field. यो thumb ले के represent गर्छ? current. Clear? battery बाट pass भएको current, and this curl thing, this denotes the magnetic field, magnetic effects. Clear? कुन चाहिँ directions मा हुँदैछ? You have to remember when current is in downward, then the magnetic field, the direction of the magnetic field will be in the clockwise direction. अब suppose current is flowing in upward directions, माथिपट्टि current flow हुँदैछ भने magnetic field को directions कता हुन्छ? Okay, this will do with the right hand thumbs rule. This is the thumb and this is pointing upward, means current is in upward directions, and this call part is the magnetic field. When the current is in upward directions, then the magnetic fields is in, that is the clockwise directions, anti-clockwise direction. Now we can say that when the current is in downward direction, then the direction of the magnetic field will be in clockwise, and the current is in upward direction, then the magnetic field is in the anti-clockwise directions. With this right and thumbs rules, we can easily identify the directions of magnetic field.